Okay, let's find the diameter of a binary tree. Okay, we are given a root of a binary tree. We need to return the length of the diameter of that tree. So basically, a diameter of a binary tree is the length of the longest path between two nodes in that tree. This may or may not pass through the root. The length of a path between two nodes is represented by number of edges between them. Okay, so from that question we can know that we need to find what is the maximum path between two nodes in a binary tree like this. Okay, in this case the maximum path will be this one. So we need to return what is the length of the path. The length of the path is the length of the edges, that means these lines. In this case here three lines are there, 1 2 3. Either we can take like this or we can take like this, both are fine, both will return the same answer. So that's the thing we need to find out. Suppose if our tree has a node here and some value in it, and it has this side also some value, and also a left and a right. Now in this case what will be the maximum result we can get? So let's see, uh, like this we can get the maximum. You can go from here or any side. From this answer we get that answer would be 1 2 3 4 5 6. The answer we will get is 6 from this tree. Okay, so I think you guys got the answer right. So how am I going to solve this? Is simply I'll just go uh, count the depth of each subtree. When I am at this node, I will take a look how what is the depth, maximum depth of this tree. In this case 1. Okay, then also check in the left what is the maximum depth, 1 2, in this case 2. Okay, and then I will add these two things, that is 2 plus 1, which is equal to 3. Similarly I also check on all of these nodes. Okay, in this one what are the depth, maximum depth, 1 plus 1, and what would be the final answer, 1 plus 1, which is equal to 2. In this case in this node what is that, here is null. In both sides this is null. Okay, in this case what will be the answer, when null occurs we need to return 0. Okay, 0 plus 0 0. So what I'm going to do is we will calculate the maximum depth in each level and return from there. That's the thing I am going to do. Okay, so I think you guys got the idea there. So let's check a dry run here. In this case first we will calculate the length of the left subtree. Also there may be a possibility that maybe our diameter will look from like this if here are also some nodes there. So we need to track a global variable, let's call it as, okay, for now let's call it as result, and it will track the maximum diameter. Okay, now let's just try a dry run. Okay, we need to get the left subtree's maximum, so we will check in this one, also this one. Okay, in this one both sides are null. Okay, similarly this side also null. So when null occurs, we just return 0. Okay, then we will calculate 0 plus 0. If it is greater than the current result, let's initialize the current with 0. Okay, if it is greater, no it's not, or no it's not, so we don't need to update this. Then what will it return from here? We will return whatever the maximum we get in both sides. Both are same, so we just return 1 because we need to calculate this one. So whatever the maximum we get, and we will add 1 for that node, and just return. So from here we will just return 1. Okay, it's not clear. Okay, we will return 1, so that one will came up here. And similarly we will calculate the left side also. These two are 0. Okay, if 0 greater than result, nope, so it adds 1 and return 1. Now from this node we will sum these two up, and we will get a result 2. If 2 is greater than 0, yes it is, so update. Then add 1, 2 plus 1 3, that 3 will return here. Similarly we will calculate the left side. Here null, so return 0, 0 not greater than, so we will just return 1 from here because adding that node, so it returns 1. 3 plus 1 4, 4 is greater than 2, yes it is, so just add 4, the loop is over, just returns the 4. Okay, oh sorry, here we are returning 1. Okay, we will get 1 here, and we will just only take what is the maximum. Oh, I just messed up. Okay, here we are getting 1 from here, and also here 1. We will just calculate. Okay, we will just return any one. We will return 1, that will came up here, and also here we will get 1. Sorry, we will get 2 here because 1 is returned from here. 1 plus 1 2. Okay, there will be the maximum 3. Okay, so let's solve this. Okay, and in this case what I'm going to do is I'm just going to create a function, a helper function, so that will make our code little bit cleaner. So I called it as device, and I am going to pass the root node here, and also I need to track of the result, so I will create a variable, global variable result, and I will just return that from here. Okay, and what I'm going to do is I'm going to implement this function dfs, and what would be our base case? The root will be going to be null, so in that case we will just return 0. Okay, then we need to calculate the left and right maximum depth, so that will we get it from here by recursively going to the leaf and return from the. After that we will calculate assign the result as whatever the maximum we get from the left and right. Okay, so we will set the result as at each level. Okay, for that I will create a function called max. It just returns whatever the maximum from those two elements. Then I will just return whatever the maximum is in the left and right, and add 1 into it. So that's the only thing we need to do, and this is it. This is our answer. So thank you for watching, and if any queries or any doubts, something like that, please feel free to comment down. And also I'm starting to upload videos like this, and if I'm making any mistakes or anything I need to improve, just feel free to comment it down. Okay, I'm ready to improve. So thank you very much. Okay, bye.